Hello everybody, it's me, Code Trucker Looter, signing in for another episode of the Learn C Sharp Programming series. And here we have the second section of this chapter 2, which is called which is called variables. So we're going to talk about all about variables. You guys have seen a lot of variables, types of variables in Python, JavaScript, but the variables in C Sharp are actually there are more because C Sharp is a lower language, a lower language than Python and JavaScript. So the theme that I have here is basically you and I were gonna basically we're gonna read all this section, and here every time that code appears in the example, I have here my Visual Studio with all the basically get ready to type out the variable example that we have, and then I'm going to basically input that variable in a console line. So for example, when you guys see this data type variable name, okay, the variable name or any other thing. For example, what could be a good example? I don't know. You guys are gonna see, but the reason what I'm gonna do this is because this code that I'm gonna be writing, it's gonna be uploaded into the repository that I have in my GitHub that you can actually see in my description, and then you can take that example and use it in your own code, so you can support the repository with a fork or anything else that you want to add to chip into the learning of the programming language. So without further ado, guys, let's get into C# programming. So variables. Variables are defined as a named memory location that can be assigned to a value. There are several types of variables, including the following. Local variables. These are variables that are defined within a method and their scope is local to the method. Method parameters. These are variables that hold the argument passed to a method during a function call. Class fields. These are variables that are defined in the scope of the class and are accessible to all of the class methods and depending on the accessibility of the field to other classes too. Array elements. These are variables that refer to element in an array. In this section, we will refer to local variables, which are variables declared in the body of a function. Such variables are declared using the following syntax. Data type, variable name. Okay, so the data type, basically the variable type, right, and the variable name. So for example, data type would be integer, and then the variable name will be, I don't know, like number 1 or first number or something like that. In this statement, data types is the data type of the variable and the variable name is the name of the variable. Here are several examples. Bool f char ch is equals to x, integer a b equals 20, c equals 42. What else? A equals -1, and what else? F is equals to true. In this example, f is an initialized bool variable. Uninitialized variables cannot be used in any expression. An attempt to do so will result in a compiler error. All variables must be initialized before they are used. A variable can be initialized when declared, such as with ch, b, and c. In the preceding example, or at any later time, such as with a and f, multiple variables of the same type can be declared and initialized in a single statement separated by a comma. This is exemplified in the preceding code snippet with the integer variable a, b, and c. Naming convention. There are several rules that must be followed for naming a variable. Variable names can consist of letters, digits, and underscore characters. You cannot use any special character other than an underscore when naming a variable. Consequently, at sample, pound tag, name percent, and so on are illegal variable names. The variable name must begin with a letter or an underscore character. The name of the variable cannot start with a digit. Therefore, too small as a variable name will throw a compile time error. Variable names are case sensitive. Therefore, person and person are considered two different variables. A variable name cannot be any reserved keyword of C#. Hence, true, false, double float, variable, and so on are illegal variable names. However, prefixing a keyword with I forgot how it's called, this one, but basically enables the compiler to treat them as identifiers rather than keywords. Therefore, variables names such as @true, @return, @var are allowed. These are called verbatim identifiers. Apart from the language rules that you must follow when naming variables, you should also make sure the names you choose are descriptive and easy to understand. You should always prefer that over short, abbreviated names that are hard to comprehend. There are various coding standards and naming conventions that you should adhere to one. These promote consistency and make the code easier to read, understand, and maintain. When it comes to naming conventions, you should do the following when programming in C#. Use Pascal case for classes, structures, enums, delegates, and constructors, methods, properties, and constants. In Pascal case, each word in a name is capitalized. Examples include connection string, user group, and XML reader. Use camel case for fields, local variables, and method parameters. In camel case, the first word of a name is not capitalized, but all of the others are. Examples include user ID, XML document, and UI control. Do not use underscore and identifiers unless to prefix private fields such as in first name, and underscore last name. Prefer descriptive name over abbreviations. For example, prefer label text over LBL text or employee ID over EID. You can learn more about coding standards and naming conventions in C# by consulting additional resources. Implicitly typed variables. As we have seen in previous examples, we need to specify the type of a variable when we are declaring it. However, C# provides us with another way to declare variables that allows the compiler to infer the variable type based on the value assigned to it during initialization. These are known as implicitly typed variables. We can create an implicitly typed variable using the var keyword. Such variables must always be initialized and on the declaration because the compiler infers the type of the variable from the value that it is initialized with. Here's an example. Implicit type variable example. We have var a Since the a variable is initialized with an integer literal, a is considered as an integer variable by the compiler. When declaring variables with var, you must keep in mind the following. An implicitly typed variable must be initialized to a value at the time of declaration. Otherwise, the compiler has no reference to infer the variable type and it results in a compile time error. You cannot initialize it to null. The variable type cannot be changed once it is declared and initialized. Information box. The var keyword is not a data type but a placeholder for an actual type. Using var to declare variables is useful when the type name is long and you want to avoid typing a lot. For example, dictionary string, key value pair integer string, or you do not care about the actual type, only the value. Now that you learned how you can declare variables, let's look at a key concept, the scope of variables. Scope in C# is defined as a block between an opening curly brace and its corresponding closing curly brace. The scope defines the visibility and lifetime of a variable. A variable can be accessed only within the scope in which it is defined. A variable that is defined in a particular scope is not visible to the code outside that scope. Let's understand this with the help of an example. So I have class program, static void main string, argument for integer. So let's create here static void main. Here we're going to create a private class, private class, create a void, private void, scope understanding. Okay, we have here for integer I equals 1 when I is less than 10, I plus plus, right line, I 20, 20, oh. Is out of scope. Right. Oh. Name I was not seeing in the current context. Right, in this example, the I variable is defined inside of the for loop, hence it cannot be accessed outside of the for loop as it goes out of scope once the control exists. The loop exits the loop. You will learn more about the for loop in the next chapter. We can also have need scopes. This means a variable defined in a scope can be accessed in another scope that is enclosed in that scope. However, the variable from the outer scope are visible to the inner scope, but the inner scope variables are not accessible in the outer scope. The C# compiler won't allow you to create two variables with the same name within a scope. Okay. Let's extend the code in the previous example to understand this. Okay. So I have integer a 5 for integer I. And then we have here character a equals w. Compiler error, right? There will be compiler error. Compiler error. We have here an if statement saying if I, the remainder is 2 equals 0, constant right line, I plus A is within the scope of main. Well, in this case it's not. But I is out of scope. Okay. So just for the heck of it, scope. Understanding. Okay. Alright, let's get back into it. Understanding constants. There are some scenarios in which we do not want to change the value of a variable after it is initialized. Examples can include mathematical constants, pi, Euler number, and so on. Euler, whatever. Physical constants, Avogadro's number, the Boltzmann constant, and so on. Or any application-specific constants. The maximum allowed number of logins, the maximum numbers of retries for a failed operation, status codes, and many others. C# provides us with constant variables for these purposes. Once defined, the value of a constant variable cannot be changed during its scope. If you try to change the value of a constant variable after it is initialized, the compiler will throw an error. To make a variable constant, we need to prefix it with the const keyword. The constant variable must be initialized at the time of declaration. Here is an example of an integer constant initialized with the value 42. Okay. Const integer a constant equals 42. Okay. It is important to note that only the built-in types can be used to declare constants. User-defined types cannot be used for this purpose. Okay. Reference types and value types. The data type in C# are divided into value types and reference types. There are several important differences between these two, such as copy semantics. We will look at these in detail in the following sections. Value types. Oh, shit. Oh, okay. So that is already part of the other section, and we are going to leave it like that. Reference types and value types. Alright guys, oh fuck. That is for today. It was a really short very short how you call it course or assignment, but at the very least we got the variables tackled down. Next time I'm gonna make sure to do 2 understanding constants and possibly references types and value types, so we can tackle 2 assignments in one go. So if you want to give a like to this video, I would greatly appreciate it, and that will keep you forward to making more videos about this. And this already got my Python course this is already my third course, which is the C Sharp, and tomorrow's gonna be my JavaScript course. And on Thursday, I'm gonna try to implement my new course, which is gonna be about game design. So yeah, that's gonna be pretty cool. Pretty cool. So thank you very much, guys, and see you guys next time. Bye bye.